Assalamualaikum dan salam sejahtera. Chapter 9, Center of Gravity and Centroid. My name is Rustam Remejana, Faculty of Mechanical Engineering, Universiti Teknikal Malaysia, Melaka. This time, I talk about center of gravity and center of mass for a system of particles. What is center of gravity or COG? It is a point that locates the resultant weight of a system of particles. For example, we have a body that contains many particles. So where is the location of the resultant weight that represent the whole particle of the bodies? For example, we have 3 particles here with the weight of W1, W2, and a finite number of Wn. That's located in X, Y, and Z coordinate system, where the location of the particle 1 is S1 bar and Y1 bar. The location of the particle 2 is S2 bar and Y2 bar, and the location of the particle N is Sn bar and Yn bar respectively. This system can be equivalent to a single particle of the system, which we can represent the 3 particles which are the resultant of a WR located in S, Y, and Z coordinate system, where the location of the particle is represented by the S bar and Y bar. Then from these 2 systems, if we look at the total weight of the system, on the left side, on the left system, we have W1 plus W2 plus Wn. Since this system is equivalent, total weight is equivalent or similar to the right system is WR. The total weight of the left system and the total of the right system is similar. Next, we look at the total moment of what exists on the both system. On the left system, first we have W1 S1 bar, that the moment that produced by the particles W1 around the axis is equal to W1 times S1 bar. For the W2 particle, we have W2 times S2 bar, and Wn particle, we have Wn and Sn bar. So the total moment about the x-axis at the summation of this moment, W1 S1 plus W2 S2 plus Wn Sn, and this the total moment of the about the x-axis is equivalent to the total moment of x-axis for the right system, which are equal to the WR times S bar. So we got an equation about the total moment of x-axis, where we can simplify or we rearrange the formula to get the S bar is equal to the S1 plus W1 S1 plus W2 S2 plus Wn Sn over the WR, or is equal to the W1 S1 plus W2 S2 plus Wn Sn over the total of the weight W1 plus W2 plus Wn. So it can be equal as the summation of the Ws over the summation of the W. From this equation, we can derive or can determine the location of the S bar. This means is where the center of gravity in S direction for the system of particles. So if we can say that the sum of moment has been used to determine the center of gravity. Similar to the y-axis, we have take the total moment about y-axis. So here we have the y bar is equivalent to the W2Y2 plus W2Y2, W1Y1, and Wn over the total of moment W1 plus W2 plus Wn. So similar to the above of the S bar, Y bar also equal to the summation of the Wy over the summation of the W. If we are looking also for the Z bar or the center of gravity in Z direction, we can conclude that the Z bar is equal to the summation of Wz over the summation of W. So, is how we can determine the center of gravity for a system of particles or for a body that contain many particles. So, if we simplify this particle, or we have many particles, or we have an infinite number of particles, we can divide the particle, or we can define the particle as a particle differentials dW. So we can conclude that the S bar is equal to the integration of SW of the integration of dW. Similar for the Y bar, we can determine the center of gravity in y direction is equal to the integration of yw over the integration of dw. And similar to the zw, we can define as integration of zdw over integration of dw. This is what we call the center of gravity, which is related to the resultant weight of the system. But since we need to study about the dynamic responses or the acceleration motion of body, it's important to locate center of mass. So we are doing this by substituting the W with G dot dm, where G is the gravity of force and dm is the element mass of the body. If we replace the dw with gm, since gm is a constant, we can simplify the formula of center of gravity to become the S bar become the integration of S dm over the integration of dm, where dm is the partial mass element of the body. And also for the Y bar, we can define as integration of y dm over the integration of dm, and for Z bar is equal to integration of Z dm over dm. This is what we call center of mass. If the body is homogeneous or the density of the body is uniform, where we can say that its density is constant, we can define that dm is equal with rho dot dv, where is rho is the density of the body. If we replace rho dm with the rho dv, we can cancel out the rho or the density, then we can get the new formula for the S bar is equal to integration of S dv over the integration of dv. Similar for Y bar, we can get is equal to the integration of y dv over the integration of dv. This is what we call centroid of volume. Also for the Z bar is equal to integration of Z dv over integration of dv. If the height or the length of this volume is constant, then we can replace, since the area times the length of the body is equivalent to volume, so we can replace dv equal to L dA, then we can get a new formula for the S bar is equal to integration of S dA over integration of dA. Y bar is equal to integration of y dA over integration of dA. This is what we call center of area, where we consider that the height or the length of the volume is constant, so we can get the centroid of the area itself. Next, if we assume of the area along of the body is constant, for example a pipe, so we can divide the volume with the area, so we cancel out the area, then we can get the length of the body. So we can define the S bar of the body or the pipe is equal to the integration of the SDL over the integration of DL. Similar to for the Y bar is equal to integration of y dl over the integration of dl. This is what we call centroid of line. So the centroid's meaning is the center for a geometry. Important points about the centroid, okay, is that is the center of geometry. However, if the body is uniform of homogeneous, the center point is coinciding with the center of gravity or mass. For example, we have a geometry of triangle. where the centroid for the triangle is 1/3 from the left side and the bottom side of the triangle. If we have another homogeneous body with the form of triangle, since the body is homogeneous or uniform, so we can get that the center of gravity for this body is similar to the central point for the triangle geometry. It's located at 1/3 from the left side and 1/3 from the bottom side. But if the body is non-homogeneous or non-uniform about its density, so the center or center of gravity of this body may not similar to the center of the geometry. So this is the first point about the centroid and the center of gravity. The difference between the centroid and the center of gravity. Second one is the total moment of all parts of the body is equivalent with the total moment of the resultant system. For body, we have many moments, I think, at many direction. But if we simplify this system to become a single force system, then we can define that the system is equivalent to the WRS bar, and where is acting at the center of gravity for the body. So this is what the meaning of the center of gravity, where we can represent the whole loading or the whole moment with a single point of action. And the third one, the center may not necessarily located on part of the body. For example, we have a ring where its center of gravity is located at the center of the ring, where it's not part of the body. So these are the three main things that we need to understand the definition of the centroid, the different, and the similarity between the geometry and the homogeneous body. Next, let me see the procedure for the analysis. First, we need to select an appropriate differential element. For example, we have a triangle with the equation of y equal minus x plus 2 for the slope of the triangle, where it cross the x-axis at 2 and cross the y-axis at 2. So we need to select whether it's line element dl, area element dA, or volume element, partial element. For example, in this triangle, we are going to select the area element because it is an area. Because in 2D, so we select the dA area or dA element. Next, we locate the coordinate x, y, z for the element. So we define the differential element to derive or to define the center of gravity for the area. So here we take an arbitrary point of x, y, where at this point we select the horizontal element of dA. So it's different on location. This horizontal element has the size or the area size of dy time with the x, and the centroid or the center of gravity for this element located at the center of the element, where is s bar, y bar is equal to s over 2 and y. Next, we need to express the element size or the partial element in s, y, and z, and dx, dy, and dz terms. So what is the dA? Element size of dA is equal to x dot dy, the height time with the width of the area. So here we have the element of dy here. So we need to make sure that in this equation, if the element is dy, so the equation must be in terms of y. So we replace the s with the bracket minus y plus 2 dot dy. So we have the element of dy with the formula in terms of y. Next, we need to express the moment arms in s, y, and z terms. This means we need to define the s bar and y bar for the element. Here, the S bar and Y bar, what we call moment arms, is equal to, for S bar is S over 2 and Y bar is Y. The third step is integrate the equation. How we're going to integrate is, first we need to substitute the formula that we have above, the element size and the moment arm, into the COG or centroid equation. That means, for example, the Y bar is equal to the integration of Y dot dA over the integration of dA. So we replace the above formula of dA and S bar or Y bar into this formula. So we get the Y bar is equal to the integration of Y in time with the bracket minus Y plus 2 dot dy divided by the integration of bracket minus Y plus 2 dot dy. So if you look here, we might make sure that the term of the above formula is similar with the element term. So if we look this formula, the element term is dy. So we might make sure that the terms in this formula also must be in the same term, that is y. That's why we need to change the term of s into y, because in this formula we have the element size of dy. Since next, we put the limit of the integration, which is the thickness of the element, that is from 0 to 2, and then we get the integration of 0 to 2 for the y bracket minus y plus 2 dot dy divided by the integration of 0 to 2 minus y plus 2 dot dy. So we solve this equation, then we get the answer of 2 over 3. Here, the y bar or the center of gravity for the y direction is equal to 2 over 3. How about the s bar or the center of gravity for s direction? So instead of taking the element of dy, so we can replace this to the element of dx. Where, for example, here, instead of horizontal element, we take the vertical element, where we can get the size element of dA is equal to y dx. So we have the element term is dx. So here, we can define dA is equal to bracket minus s plus 2 dot dx. Previously, the element is dot dy. So this time we have the element is dot dx. So we need to convert the formula, all the formula in term of s. And then we define the moment arm of s bar as at, and y bar is y over 2. And again, we replace the two formula dA or the element size and the moment arm into the equation of COG. Then we get is equal to the s bar is equal to integration of s dot in bracket minus s plus 2 dot dx divided by the integration of in bracket minus x plus 2 dot dx. So if we look in this formula, all the term in this formula, since the element term is dx, so the formula term also must be in x. So we need to manipulate the formula to replace all the formula in the same term, it is x. And then we replace the limit of the integration from 0 to 2, and we solve the equation, then we get the s bar also equal to 2 over 3. So this is how we do we determine the center of gravity or the centroid for a body or geometry. So there is 3 steps. First step is we select the differential element. Second step, we express the element size and moment arm. And third step, we do the integration by replacing the element size and the moment arms into the equation of COG. Then we solve the integration and then we get the answers. In for selecting the differential element, so if the y is easily defined by x terms, select a vertical differential element. For example, if the y is equal to x squared plus 1, since it's easier to integrate the term of x, so we select the differential element vertically. But on the other side, if x is easily defined by the y term, Then we select the differential element in horizontal element. Okay, that's all about the center of gravity, how to solve or how to analyze the procedure to find out the center of gravity for a body or centroid. Thank you and selamat maju jaya.